Hello, my name is Kirtana Kumar, and this is my Physics2Lab1 lab report. The purpose of this lab is to observe the interactions between two charged pieces of clear tape. At the end of the experiment, we'll determine the excess amount of charge or electron deficit on one piece of tape. The results that we've gotten, the observational model had a charge of 3.49 times 10 to the negative 7, which is very similar to the computational model. And the amount of excess electrons on one piece of tape was 2.19 times 10 to the 12th. The main physics ideas used in this experiment were Newton's second law and Coulomb's law. Newton's second law describes the concept of F net equals mass times acceleration, which is used in this experiment to calculate gravitational force on the tape. And Coulomb's law is a formula used to calculate the amount of force between two charged particles, where F net is equal to this formula over here. And K, in this formula, K is a constant and equals 9 times 10 to the 9th. Q1 and Q2 are point charges, and R is the distance from the observation location to the particle. So the setup of the experiment is shown in this image. The initial conditions for our experiment were that the tape mass was 0.07 grams and the tape length was 0.07 meters. In our experimental setup, it was the opposite of what is shown in the image here. So our system was actually the bottom tape and the surroundings were the top tape and everything else. And we found the distance between the two pieces of tape to be 0.04 meters. So in the observed model, we use Newton's second law. The force of gravity is equal to mass times acceleration, or in this case, Fg equals mg. This resulted in a gravitational force of 0.686 newtons. And due to the net force of the particle equaling 0, the magnitude of the gravitational force and the electric force must be the same. So knowing this information, we can calculate the charge of a single particle by solving for Q using Coulomb's law. And here I rearranged the equation to solve for Q. And after solving for this equation, the particle charge was equal to 3.49 times 10 to the negative 7. And in order to find the amount of electrons we lost, we put the charge of the particle over the charge of an electron, and we received 2.18 times 10 to the 12th electrons as the amount we lost. So for the coding portion of the lab, the green force is, or the green arrow, represents the electric force, which is equal and opposite in the magnitude of gravity. And the orange arrow represents the gravitational force, and the yellow arrow represents the direction of the electric field due to negative charge. Here we can find the respective code for each of the gravitational and electric forces, and then this is how to find the charge of one piece of tape. And this represents the E field and how to find it, and these are the constants I used in this coding project. So both the observed and computational model achieve similar values, although this may not have been purposeful. It's important to note that there were many variations to consider in the computational model. So there was no air resistance or drag, and the tape was represented by a point charge. And along with these assumptions, each piece of tape had around the same charge, and it was pretty evenly distributed during the experiment, so we calculated the particle charge based on that. And we also did not weigh the mass of the tape, and we assumed the mass of 1 meter of tape is equal to around 1 gram. Possible sources of error include incorrect handling of tape, which results in loss of charge, repeating the experiment multiple times with the same tape pieces, which could result in an overall less charge or less dramatic result, and the only forces in the surroundings that were being considered were the electrical and gravitational forces. Some additional questions. If electrons had a positive charge and protons had a negative charge, nothing would change about the observations in this experiment, because switching the charges doesn't change the fundamental fact that like charges repel and opposite charges attract. However, instead of electrons being lost in this experiment, it would have been protons. And it's important to handle the charged tapes as little as possible in order to prevent loss of charge onto different objects. This can result in making the tape more neutral and therefore the effects of the experiment less effective.